Huge welcome to everybody across Sussex and I think beyond to our second session about teaching primary maths remotely. This one is all about building reasoning and problem solving into remote learning. When we were thinking about putting the session together, I think one name just sprung to mind about who we wanted to get involved in this. And so I'd like to say huge welcome and thank you to Gareth Metcalfe, who's joining us today. And he's going to share his words of wisdom with all of us. And we're hugely excited. And you can see that by the numbers who have turned up today at 4 o'clock on a Thursday, towards the end of this manic half term, to listen and to learn more about how we can improve our online and remote offer. And actually, beyond that, take this into our classrooms when hopefully we get back to being face to face with all the children. Reasoning and problem solving is something that we're all passionate about at the Hub, because it is something that mathematicians, real mathematicians, do. Doug Williams, in his article An Ocean of Possibilities, which is one of my favourite, talked to a year one teacher who, when he asked the question, what do real mathematicians do? And one response was, they solve the hardest problems. And that's what it's about. That's what maths is about, problem solving and reasoning. Another response was, well, if you want to know what mathematicians do, first give me an interesting problem and I'll show you. And he says, now there's a guide for developing a mathematics curriculum. And this is at the core, really, of what we're doing with our 5 big ideas of mastery. And here in the mathematical thinking section, we are talking about if taught ideas are to be understood deeply, they must not merely be passively received, but must be worked on by the student, thought about, reasoned with, and discussed with others. And even though we're working remotely, this is how we're challenging our pupils. All of them, they all deserve that rich diet of reasoning and problem solving. Again, I love this quote here from Enrich, another fantastic place to look. Reasoning is fundamental to knowing and doing maths. Some would call it systematic thinking. Reasoning enables children to make use of their other mathematical skills. And so reasoning could be thought of as the glue which helps mathematics make sense. And in our national curriculum, it talks about a high quality mathematics education, providing the foundation for understanding the world, the ability to reason mathematically, an appreciation of the beauty and the power of maths, and a sense of enjoyment and curiosity about the subject. It is what real mathematicians do, which is why we have invited a real mathematician, a real educator of mathematics that we all love and respect, Gareth, to talk about what he's been doing and generating over the past few years. This is a glimpse of his website, I See Maths, Learning That Sticks. If you haven't looked here already, please go and visit it. It is a treasure trove of resources, from his free home lessons that he produced last year in the first lockdown, and his inspirational blog. Here's something on early number sense, but he's also done lots of things like variation and reasoning and problem solving. There's resources, some of them free, some of them to purchase at a very reasonable price. It's just a brilliant place to go, and we highly recommend it to all the professionals that we are working with. And you can see that many of them have turned up today to hear it from the man himself. So at this point, I'd like to, I'll stop sharing my screen and I'll hand over to Gareth.
Well, fantastic. Thank you so much. It's very humbling to hear those words. This will start. Yeah, so what I'm going to do, let me just, I'm no good at doing 2 things at once. So bear with me whilst I go from the beginning of what I was going to present today. And it's fabulous. It is fabulous to see so many names. As Andrew, Jeffrey, who's here. I've seen, you know, fabulous to have you here. Great. And as I say, friends and colleagues as well. Just to say, again, for any of those that have just come in, any questions that we've got on an ongoing basis, if you throw them in the chat, then I would love for our other panelists to interrupt me and to get your thoughts directly into what I'm doing today. And what I'm aiming to do is, I guess, share my meandering experience and my thoughts around reasoning and problem solving in remote learning. Now, essentially, this story goes back to my daughter's birthday party. So my younger daughter is 5, and we kind of had started to see, like, it was dawning on us slowly that actually school's going to be closed for a while. And I was chatting to one of our friends, and I said, you know what, I'm going to put a lesson on for children in year 3 and 4 and 5 and 6 during the lockdown. And I had no idea quite how long that would be, and actually how much fun it was. But what I'm going to do is try and share some ideas and thoughts around what worked for me. And what I would always encourage you to do is think, how will that apply for me in my context? And there'll be bits that will and bits that won't, and question everything that I say and doubt everything that I say, ask questions, and think, how is this going to work for me? But I hope the principles stand up in terms of your maths pedagogy in the long run, and also are helpful right now. And with that, I'll kind of get on with the actual content. What I wanted to do is think about how we can design tasks and activities. And I guess this was the thought process that I went through, was how am I going to make this accessible with the scope for depth for all children during those, when I was putting those remote learning lessons together. And I guess the first thing that I thought is, when I was planning out what the content will be, I was thinking, what's going to work best in a remote learning setting? And I guess the first thing I would encourage you to do is maybe we think less about what's on the plan for the year and more think, actually, which aspects of the curriculum lend themselves to this forum, and focus there. And also, one thing that I thought is, actually, what I don't want to do is where I've got to introduce things that are more looking at procedures with lots of different steps. I thought that's going to be difficult to communicate in this forum. What I wanted to think more is, how can I look at big mathematical ideas that we can explore, that children can access in different ways? And that was that is something that I believe is really important. Anyway, I often think that the procedural understanding can be a bit of a byproduct of that number sense. And so what I wanted to do was just share a few techniques that I used around that, looking at numberless questions to introduce structures, which is something I love talking about, looking at the use of contexts, where there's some limitation on the visual representations that you would normally be able to use, how we could use context, and that can be powerful as well. And then the thing that I wanted to finish with was around variation and the power of variation, and how we can kind of leverage that to get all children able to access mathematical ideas and for there to be scope for deepening. Now, it'll hopefully that I can put some flesh on the bones as we go through, and I'd kind of love to get your thoughts there. So the first thing that I wanted to do, and this is an example I always like sharing, and actually I thought there's a member of staff, I'll not keep going on about this, but someone that I've worked with for a number of years, and this was actually done in his school. So we had Zara, and we had the sandwiches cost £1.80, drinks cost 30p. And what I've done is I've taken the information that is in the question, I've covered it in a blue box, and I've put the question, and I've covered the question in a red box. And I've done this in so many instances since to explore the deep structure and ask children. So there's information under the blue box, and you need that information to answer the question that's underneath the red box. And so say to the children, I just want to know, what could the question be? And what they want to do is they want to tell me the information and the question. So we want to help them to separate the information from the question. So say, for example, the question was, like one example question could be, how much change does she get? Now, I actually did this at a school in Manchester, and this really made me laugh, because one of the members of staff said, are the sandwiches gluten-free? And then if that was the case, I guess underneath the blue box, it could be, Zara is celiac. Are the sandwiches gluten-free? So then we've got information and question. It could be, let's say, if the question was, how, like the children would want to say, she buys, 4 sandwiches and 2 drinks, and she pays with a £10 note, how much change does she get? And so we say, so there, what's the question? And of course, the question is, how much change does she get? So we're saying, if that's the question, what information must correspond to that question? Now, can I just give a moment for you to, just in this instance, and just fire them in the chat, and then the panelists can bring up any that are common. The different questions that may be, and I've written 3, the different questions that may be underneath the red box. And if you can try and only give the question, not the information that is required to answer that question, but just the question in the chat, that would be great. And then if you could read them out for me, that would be marvelous.
So we have got how much is spent in total?
How much is spent in total? Yeah, like that.
How much more does she need?
How much more does she need? Yeah, I love that.
How many sandwiches can she buy?
How many sandwiches can she buy? Okay.
Does she have enough money?
Does she have enough money? Yeah, that's very nice. That's very nice. And just maybe one more, if there is one more. That's a great coverage.
How much over the week might she spend?
Okay, wonderful, wonderful. Now, anyway, let's say we come up with that list of questions. And then what I would look at, and what we looked at was, well, if that's the question, what information corresponds to that question? And now children are having to think about the deep structure, rather than essentially seeing numbers and rushing to do something with them. We're trying to expose the deep structure. And so I've thrown up 3 of those examples that came up. So how many sandwiches can she afford? So actually the question is, how many sandwiches can she afford? What information must be underneath the blue box? And then again, we're having to think about the structure before we actually look at calculating the answer. And we get to that. It must be how much money, in this case, she has to be able to answer how many sandwiches can she afford? And then we throw up what that is. Now, equally, if it was how much, and this was one of the examples that came through, that links to change and does she have enough money, or how much more money does she need? And then say, so what information must be under the blue box? And eventually we get to, well, what does she want and how much money does she have? And then we start unpicking, right, well, there's got to be, there's a link between those two that means the question is, how much more money does she need, rather than how much change does she get? And the reasoning that we get to is, however much, whatever she wants, she's got to have less money than that cost. And then we compare that to, having looked at an example, to, well, how much change does she get? Now, this is a technique that I love for getting children, first of all, exploring deep structures. And in a remote learning context, this might be where some guided teaching comes in to explore those structures. So if I just show you another one, this again has always made me laugh, because Jenny and Adil are running a race. They are timing how long it takes them to run 800 meters. They've finished, and yet they're both smiling. Now, we know that never happens. One is smiling, one is crying. However, if you kind of bear with the fiction, the timing, how long it takes them to run 800 meters. And so again, I could say here, so what could the question be here? Or let's say, and again, I've loved exploring the different ways I could reveal the information. So let's say we see Jenny ran 800 meters and we know how many seconds. And again,
Just frozen, Gareth.
While Gareth is just slightly frozen, perhaps I'll just quickly launch our poll to make the most of it. So if everyone online at the moment would just be happy just to let us know which area your school or organisation is from, just so that we get that great sense of where everyone's from today. Thank you.
I noticed we had people in from North Wales, which is fantastic. Essex, Hampshire, earlier on in the chat box.
Brilliant.
Gareth just rejoining.
I think so, yeah.
Yeah, get a new connection.
It's always a tricky time of day when everybody, 5 o'clock is always the maximum. Not enough Wi-Fi to go around. Nearly got everyone's. We have got substantially most people from Sussex, which is, it's great to know that people locally have been able to make the most of the opportunity.
What's it telling us, Rebecca, the data?
So we've got about 68% of participants are from Sussex.
Yep.
2% have come to us from Kent.
Mhm.
Nobody currently from Surrey. And then 30% of the attendees have come from other areas, which were being listed in the chat box. If anyone hasn't put it in, please feel free to let us know where you've come from today. So most people are from our local area, which is great because we can follow that up now together.
James says the Wi-Fi disaster has struck again, but it's worth staying. So yeah, we will.
Yeah.
We will stay. I'm wondering whether I should send. I might send the link again to Gareth in case you could get in with my link instead.
Yeah.
Oh, Lincolnshire panelist,
Wow.
attendee from Lincolnshire. Fantastic. So I'm gonna end the poll now there. So
Thank you very
see
much.
that.
Rebecca.
No, that's great. Thank you everybody for taking part in that. It was really great to see where everyone's from.
I bet Gareth is scrabbling around right now. I've been in this situation myself before. It's
Just
not the
showing off there
best.
because I've got another computer to the side of me. So
Can we do a quick advert actually as well for our next webinar while we're waiting?
yeah, shall I?
Yes, please.
Shall I?
Yes,
yeah.
please, dear.
Yeah.
So we're absolutely delighted to say, please save the date at the moment. We've just been talking to Claire this morning, but Claire Christie, who is an SLE down in Bristol and part of the primary team for the Boolean Maths Hub, and really quite a prolific person in the NCTM. She's worked so much on the PD materials, register request materials. She is just an absolutely fabulous, passionate speaker as well. And we've managed to secure her. She is such a busy lady. I couldn't hardly get any dates at all this year, but we have managed to secure the 3rd of March at 4 o'clock to have Claire come along and talk all about fluency and a real focus on potentially post-lockdown fluency as well, and what we can really do to help children make progress and have a whole school approach. So I'd really recommend put that in your diary now. We're still writing the flyer as we speak, but hopefully by next week we'll have details to send out and details of how you can book. So I hope lots of you can join us again in a few weeks' time for another dose of mathematics, and hopefully again another really inspirational speaker. I know whenever I've seen Claire speak, my pen can't write fast enough all the top tips and ideas she can share. I know, Emma, we just did a course this week on introduction.
Yeah, we did.
So we'll talk a little bit about that and what we were sharing there, Claire.
Yeah, we were really looking at the fluency article that Claire wrote for the NCTM, which focuses on those key number facts that we want children to learn in year 1 and 2. And you know, I think it's so widely used nationally because we know how fundamental it is to children's understanding of maths later on. And we also know that those are the skills that hold children back. You know, they're really the ones that they seem to not have when they get up to year 6 and things. So I think it'll be brilliant to hear her speak in person. We're always plugging that number facts grid, and we talked about the need to actually track children's understanding of those facts to make sure that when they leave year 2, if they still don't have them, they're picked up very quickly and there's some form of intervention. So I'm really looking forward to hearing Claire speak, having spoken about her many times.
Excellent, thank you. And also, I know we've got Debbie Stretfield, who's also part of our audience today, and she leads on our subject knowledge enhancement training as well. So please look out for that as well as something else you can book up on our Maths Hub website. Hi, Gareth, welcome back.
Brilliant.
So I'm so sorry, that has never happened before. The internet in our house is just cut off. And
we've just done an exercise in improvisation.
We have.
And it's on again. That has literally never happened before during a meeting, we're on again. So I'm relieved about that, and real massive apologies about that. As I say, that's a first for me. But let me just see if I can I share my screen again? James is teasing me again. And see if I can slideshow. Where were we? From current slide. Right, I think we're back. Apologies, I don't know what that was. And again, we should be on now. You can hear me okay? Yeah, fantastic. Right. Sorry. So I think I was on numberless prompts, and I'd mentioned about then who ran the quickest time, and then we've got to, here we go. We've got to the different possibilities it could be with a deal, and you have to think, well, what would a winning time be, and what would make the times equal, and so on. And we go. The idea is broader to narrower. I'll keep my train of thought now. It's just another example. I never find it difficult finding the questions and essentially thinking, how can I deconstruct them to make them more open to more possibilities before narrowing down, particularly with view of understanding deep structures first, taking the burden away from the calculation aspect. So this question, essentially, I've just covered 2 of the pieces of information with boxes. So we can have possible answers to begin with. Ollie spends, and he could spend a different amount of money on a teddy. He pays with how many coins? And it's, first of all, give me a possible answer. And this might help children to kind of process the information. And having processed the information, I could then become more specific. Ollie spends 30 pence on a teddy. How many coins could he pay with? That's some different possibilities to the point where, again, I show he pays with 2 coins. Now, what I wanted to do was have a look at then how this could be used through context as well. Now, first of all, when I was exploring division, I talked about how rather than focusing too much on anything that is kind of procedural, I wanted to explore big mathematical ideas and concepts. So an example, and I will get back to contexts, but one thing that I did in the lessons to look at division was exploring using matchsticks. So again, a little practical equipment that children could use at home. With 16 matchsticks, I can make how many pentagons, how many matchsticks left over, that we can do practically and get this idea of how many in, so how many squares or how many triangles. And it might be, again, we explore around that certain misconceptions and ideas. So with 20, explain the mistake. With 20 matchsticks, you can make 5 triangles, 5 matchsticks are left over. And exploring some of those big ideas that underpin division. Then again, questions that I would often look at. How can we make questions where they are accessible, but then there's that room for depth and different possible answers. So again, it's this, we've got 23 matchsticks. So how many triangles can be made? How many left over? Squares. The idea that I'll be able to make fewer squares than triangles. And then again, if we have a look at D, with 24 matchsticks, we can make 4 and have a think, how many possible answers are there for question D as this opportunity for broadening. But what I wanted to do is then consider how, if we're somewhat limited with the equipment that we can use, how we could possibly tap into the use of context instead. So one that I've always loved using has been camping. So people camping. And I remember telling a story for this one. For my brother's 40th birthday, we went camping, and I'm going to show you how many people there were, how many per tent. So therefore, how many tents were needed. So give me what it could be. Give me a possibility. And then my assumption was that the children would come up with a possibility like this. And this is one that we model. So it could be that there were 15 of us camping, 5 per tent, 3 tents needed. And then we have equally, perhaps it was that there were 20 people camping, 5 per tent, 4 tents needed. We said, actually, it wasn't that. It was 19 people camping, 5 per tent, and tents of 5 we had. And so we say, so how will the picture be different? And so we've got this, and again, this is something that children could use with counters to model, or and we're trying to tie into their kind of real world understanding to again explore these big ideas in a way that may be able to be more accessed than whereas at school it might be there's a greater emphasis on specific visual representations. And again, here there's so many ways that this idea could be explored. Like it could be, well, actually there was another group where they were in tents where there's 8 per tent and they needed 3 tents. So how many people could be in that camping group? Which the irony is, of course, now we can't be 8 people. That seems like a lifetime ago. So how many could it be? And we get to, you know, that we're somewhere between, well, it could be, and then again, we can work through all the possibilities, and we could access that. Can we find an answer, or can we find different answers, or how many possible answers are there? And again, how will the picture look different if it were, you know, 17, and so on. So I really like the use of context, and then having that possibility for opening the door to different answers as well. Now, so again, I'd kind of encourage you to think about how that could be used. The same principle I looked at using with multiplication, of thinking how, again, can we access, oh, sorry, there's something that I've forgotten to come to. So we'll get to the multiplication in a moment. Let me just give you a moment. We're going to come later to variation as well. And I just wanted to have a look at these examples of questions. And again, it was around, so this was a little sequence that I'd used. And again, this opened up the possibility that children will read the questions and there'll be a kind of element of surprise or something for them to notice or reflect on. So that even if they were just given the answers, then the thinking could still be deepened. Now, you'll not be able to listen to me and read that. So if I could, I'll not talk again for 90 seconds or so. And again, in the chat, if you just go for what kind of things might children notice, or what am I trying to draw attention to? So again, if any of the panelists want to come in.
Yeah, sure. So we've got division and remainders coming up. Different totals. We've got sometimes the same answer, round up or down, depending on the context of the question.
Yeah.
Making sure you're looking at the question and what it's asking you and answering that question, not just answering the division.
Logical thinking.
Yeah.
Multiples.
So I guess there's the what if, you know, moving on from this, can you design another question that gives me 4?
Yeah.
You know, as a child, you'd be wondering that.
So it could be the question, the children, sorry, could extend that sequence, theoretically. Yeah. Brilliant. And again, my thinking was, like, it could be that question 5 we looked at, rather than 13 people go camping, it could be we've got 30 eggs and we need to pack them in boxes, or 13 cupcakes, we need to pack them in boxes, and actually recognizing that then the answer will be different in that context. But the thing that I like about this is the possibility that we have this surprise, that if we correctly answer question 1 and question 2, the answer is the same. And again, question 2 to question 3, it's not another 4 people camping, but it is just 1 more tent. And can we explain why? So all these possibilities for how this can then be developed from just that initial prompt. And again, the idea that we're trying to point to the big idea that question 3, we need 4 tents, and question 4, we still need 4 tents. And how can that be possible when there are 3 fewer people camping? So allowing us to kind of unpick those big ideas. And again, within this kind of line of questioning, there's so much scope for broadening and taking that in different ways, which again, I think is something that suits itself well to remote learning. Now, when in a similar way, when we were looking at multiplication, what I was looking at were we're looking at grids like this and saying how many squares, and how could you work out how many squares without counting, say. And that, again, you can access in lots of different levels. And then we had a look at the modeling and trying to be really explicit about, we could look at the different ways that we could break these numbers down, these 14 times 6, if that won't likely be a known fact, and how we could partition the 14 into a 10 and a 4. Or equally, it could be that it's partitioned into a 7 and a 7. Or maybe we don't partition the 14, maybe we partition the 6, and toying with these different ways that can be done, but through I guess a visual or a context that can be then explored by children in different ways. So when we come to like structure the questions, it could be, for example, that we give children an image like the one on the top left and say, how many squares and how do you know? It might be something more like on the right, where we're directing children to show me the different ways that 15 times 8 can be calculated, but there's some scaffold that is taken away in terms of then I've got the area model to break down. It could be I've got the different ways questions, where we have prompts that, and again, these are all from my reasoning resources, where there are prompts to direct children to 3 different strategies. And then it could, of course, be that we want children to find independently to find their own strategies to answer different questions. But again, it's looking at how can we get that same fundamental big idea and explore it in these different ways. So again, I would kind of encourage people and encourage you to think, where is it that we can explore these big mathematical ideas, perhaps in a slightly friendlier number range, and to explore all these different possibilities. And again, putting the kind of the visuals and context at the heart, I think is, for me, was a friendlier way of piecing together the lessons that I was looking to do. Now, and again, questions and comments and thoughts on all of this as we go through, please interject. I just wanted to share another couple of examples of techniques that I liked using and that I've liked using. And they are, comparing parts and wholes. I've always found a nice one before we start looking at where you can actually calculate a fraction from a part and whole relationship. So we were looking at other contexts that could be used, like comparing fractions, the neck as a fraction of a giraffe compared to the frame as a fraction of a bike, or a morning as a fraction of a day. Great opportunities again for children to kind of explore those different contexts and maybe again create their own examples. What had been fantastic through the videos was just sowing these few seeds and saying, I would love to see, and I think this works naturally with your class, I would love to see if you can generate any examples and why you chose these examples. And again, the children would love having the opportunity to create their own examples to throw into the mix as well. And I think that was really valuable in this context. I actually felt like in educational research, like there's a lot of talk around engagement, and perhaps the engagement used to have a greater emphasis than it did. And actually, when it came to home learning lessons, I thought suddenly engagement becomes very important, because we want children to be able to access these ideas, and that was one of the levers that I would pull in that way. So similarly, a little game that I'd played a few times was Odd One Out, and this is leading into a shape activity. But again, this was always a nice lead-in, and again, a lovely way for children to generate their own ideas. And in designing an Odd One Out question, I would generally look at examples where each thing can theoretically be the odd one out. So let's see if we can get 2 reasons for each food and why it's the odd one out. So again, any that come through, if any of them.
Gareth, while we're waiting for that, we know that a lot of parents and carers are feeling really de-skilled as remote teachers themselves. And we had a question a moment ago: how would you encourage parents to support children with this type of task, and the one you've just shown previously with the giraffe and the bike and that sort of thing, so that they feel confident in supporting their children?
Yeah, that's a very good idea. I'd say very good idea, very good question. And how do parents feel confident? I mean, I would say that, and again, I'm on the spot, so let me just think about what my instinct would be to have like contexts that are they don't feel like they need that kind of specialist procedural knowledge for. And if they do need that specialist procedural knowledge, then how is that kind of communicated? But yeah, that's a difficult question. I think there's certain tasks, and the other thing is just effective guided, having effective modeling and guidance rather than children kind of being just given tasks to complete. So I think that where the remote learning includes that modeling, that's important. And I'm sorry I don't have a better answer than that.
I'm sure we can talk about it perhaps again later on in the session.
Absolutely.
Some great odd one outs coming out. Who would like to share some odd one outs?
Yeah, we've got some really interesting one. And bananas, because you don't eat the skin. That was a good one.
Yeah, I like that.
Let's have a look.
Bananas are also the only ones that are in a bunch.
Yes.
Raisins are dried fruit or dried.
Potatoes are the only ones that are vegetables.
Grown underground, we had as well as some.
Yeah.
On the screen, the potatoes are the only one that are in an odd number that we can see.
Ah, okay. Yeah, very
which
nice.
I particularly liked. Yeah.
Yeah. And then and that to kind of explore that big idea, and then again we would lead into examples like the rhombus, the kite, and the parallelogram. Odd one out because, and then again, children can access this in terms of they might come up with a reason why one of the shapes is the odd one out. Obviously, having explored the language beforehand, and could they come up with a reason why two shapes could be the odd one out, or can they think of a reason for each shape why it's the odd one out? Again, any in the chat there. So let's see if we can cover all three.
Good chance to start typing.
I've actually found, Gareth, that some of the children who are very reticent to communicate in this format, this particular activity can be a really great opportunity to start to engage them to begin with. Just the opportunity to talk can be really powerful.
Absolutely, yeah, and that focus, and I guess to some extent that's something, perhaps going back to the previous question about parental engagement as well, and just giving that scaffold, I think is great. Yeah.
So we've got some answers coming in now. Emma, do you want to read some of them out?
Yeah, we've got a kite because it has no parallel lines.
Yeah, very good.
The rhombus because its lengths are equal.
Yeah.
The parallelogram, on the other hand, because it has got parallel lines.
Parallelogram has no lines of symmetry.
No lines of symmetry. Very nice. Yeah, very nice. And again, these kind of examples I thought were really useful for generating discussion as well. Now, where I wanted to, and then again, these examples where then it naturally lends itself to children creating their own examples, and that's the kind of thing where that could be something that you just dangle out there, so that for children to be able to go away and explore this idea themselves, lending to, there's this opportunity for deepening for the remote learning as well, so we can all access the main content, and then this is perhaps something that can be an additional challenge. So just one of the examples there, one of the many examples that came through. It really was a privilege during the whole time to see all the children's work coming through as well. Now the other little examples that I wanted to provide, it's kind of the same principle really. And again, I didn't want to particularly have my little internet interruption. I didn't want to spend too long here, but just the idea of, and again, all these questions I like to think are threaded right throughout all my ebooks, are questions where there are multiple possible answers, specifically using the how many ways prompt of level 1, I can find an answer, and choosing the questions where that is relatively accessible. Level 2, I can find different answers, to level 3, I know how many answers there are, because there again we've got this natural inbuilt stretch of, I can access the question if I can find a possible answer, whereas to be able to justify, I know that there are 4 answers and it's impossible that there can't be 5 because, and to be able to reason in that way, I think has enormous value. So they're kind of structures that again I really like, and again I won't kind of dwell on those examples, but just to say that I try and filter them, and that's a kind of common technique that I want to put through all my work. But let's get what I wanted to move to was then the sequences of questions. Now I call these small difference questions, and the use of variation. Now I am lucky enough to have, well, I've got my 2 daughters at home at the moment, So I've managed it, and I'm actually, of course, writing ebooks for year 3 and year 4, and I happen to have a year 4 girl sat next to me half of the day, and I thought, well, I could take advantage of that. And let me just share this little example. Now, the I know and so prompt is helping her to explicitly make connections between questions, and the connections that I want her to be able to use then when she comes to small difference questions. Now, the idea with the small difference questions and the way that I think they're really powerful, and again, Craig Barton talked about this in great detail in his book, was the idea that we can, on one level, we might be practicing the calculation, but then on another level, with the small variation between the questions, almost the thinking isn't finished if I just gave you all the answers. Because in discovering those answers, I will maybe see patterns or explain relationships, and we want children to be able to start having expectations of thinking what's the same and what's different about the question, and so therefore what will be the same and what will be different about the answer. So I really enjoyed this doing this one. Now, if I can just give you a moment to have a quick look and have a think about what do you think my daughter might have said or might have noticed, and what was the thought process behind the design of those questions?
Patterns coming in.
Fantastic. And again, if anyone picks out just an example of what could be said, or the link between this and that, that would be great. What she may have noticed.
Doubles and halves, number sense. You don't need to know everything or work everything out. You're using again some of the facts you've already generated.
Commutative law.
Yeah.
Links between calculations and connections, related facts.
And so if I talk you through some of the things that she said. So first of all, we had 7 times 3 is 21 and 3 times 7 is 21. And she filled them in immediately. And you could say it's stating the obvious. And if it is, it took a kind of 2 seconds. It wasn't time consuming. Whereas it might be that for someone else, it sets off a moment of realization. But let's say, for example, we had 6 times 8 and 12 times 4. And she actually did, and in fact, let me go back slightly further. 2 times 8, 4 times 8 is double 2 times 8. And then I want to see 6 times 8. Does she then double the 32? Or does she actually recognize that it is 4 times 8 plus 2 times 8? Because it would be common that we see the pattern as, oh, it's a double and double again, particularly when there's other double examples. But then again, she goes 6 times 8 is a known fact, 12 times 4, 10 times 4, add 2 times 4, 48. And only in writing 48 do we have this moment of the answer's the same. And then it opens it up to, hang on a minute, why is it the same? And without that variation, we don't. Now, on one level, this might be children that, let's say, at home, they may not notice that, and this may just be practice of calculation in that level of challenge. But also, we now have this opportunity, because of the way the questions are being sequenced, for opening up, and children could explain patterns, or how could you extend that sequence yourself? And it naturally then lends itself to the stretch, which again, I feel is enormously powerful, both in the classroom, but also I think has benefit in this context at the moment. And that's the place that I was always looking for the opportunities to find. So if I just share a few other examples of how that might look. So 28 plus 6, and let's say I calculate that correctly, 34, and then 26 plus 8. Now, again, maybe children will look at those questions and think the answer will be the same because the one's values have just been switched, or perhaps they calculate them separately. And in seeing the 34, we have a surprise, and it naturally then we attend to, well, why is that? And again, 36 plus 18, it could be that the children do that by adding the 10 and then adding the 8. And only again, when seeing they have the same answer, do they attend to that difference. So as a technique, I think there's great scope then for, now in the classroom, I want to really model and draw out what does an expert reader say, and and model that process of, well, what's the same about the question, what's different about the question, and so therefore what will be the same about the answer, what will be different about the answer, or what's your expectation. And now it might be that children don't have an expectation, but then in finding an answer they have a surprise, and then we reflect on that. But I think there's great scope here in intelligent practice, in that we're practicing a skill, but then we have the scope for going deeper with the sequencing. So if I could show you,
Gareth, can I just ask you a question's just come in? Sort of, how do you get parents away from seeing maths as the answer, trying to get to an answer, and maybe equip them with those sort of questions that we would use in the classroom, like what do you notice, or have you spotted a pattern? How do you equip parents to deal with that?
Yeah, I mean, that's a really good question. And I think that, and I guess to some extent that will be a question for individuals as well, in knowing their parents and their kind of level of engagement, to have that dialogue. Now, to some extent, I think it comes through, and again, it could come through what you're choosing to model, and in the remote learning that we're doing, and actually drawing out and explaining and expanding on that reasoning, I think is really important. Now, of course, there has been this sea change in the nature of mathematics education from when parents were at school and maybe their expectations. And there, I don't think there's any magic bullet that unpicks that. And parents' perception of what challenge is different. Now, how we engage parents with the fact that actually the idea that we know that where children have depth, not acceleration, is important for children's attainment in the long run, and how we communicate that message. I mean, that is challenging to do, but I guess that what I would say is that the piece that we hold is what we model, and then what we provide and what we celebrate. So that would probably be my best answers to that.
We've been talking about this a lot, actually, in the various different groups that I'm involved in. And if we were in school, we would be having a parent meeting talking about teaching for mastery and what depth is. And so if that's not the stage that you're at, I think some kind of letter or explanation of what is depth and why reasoning and problem solving is important, it could go alongside, your kind of provision as a general letter. But also an easy way around it, I think, is the signposting we use, whether it's a diver symbol or a star, so that we're showing in terms of depth and challenge what we value as challenge. And if that is consistent, and it's consistently the same kind of thing that is starred or got your diver symbol next to it, then parents as well will soon get used to, I think, understanding, well, that's obviously what is considered harder, even if they might not agree with it, and they might still think that bigger numbers make it harder, but that we value as teachers, and we're modeling that, as you say, that this is what we consider to be depth and stretch and challenge. But I think, in the situation that we're in, signposting and perhaps an explanation on our homepage about what you can expect and why would nip that in the bud or support what we're trying to do.
I agree with everything you said, Miriam, but I also think what Gareth said about what you celebrate, that's what people are going to aspire to. So if you can, in your recorded lessons, pick up examples that do demonstrate what a good one looks like, then I think suddenly you open the eyes of all the other children and all the other parents as well of, oh, that's what they're driving at. I didn't kind of realise, but when I see what a good one looks like, maybe we could try and aspire to that type of thinking and reasoning and work too. So I think that's really helpful.
Yeah, I think that's helpful. And I also think if you don't want parents to stop when the children have got to the answer, give them the answers and make the task all about explaining how those answers link. Because I know there is that temptation that once the answer's in the box, that's that task done for the day. So that's a really good way. And I know lots of your stuff, Gareth, has that with the answer already there for people to explain.
I think it's a great opportunity to kind of, if you like, address what you might perceive as status differences in a class with the children that, with wanting to see great examples of that, but also in the children that are used to draw out, some of that example reasoning as well. Let me have a look at this example, and I'm going to give you two to have a quick go at. And the basic premise here is, and again, we're the rules of BIDMAS. And basically the thing you would need to know if you don't know this already is that we would do the thing in the bracket first. If there is a bracket involved in the question, then you need to multiply before you did any subtraction. And again, if you're not familiar with that, that's the basic idea that you need to get here. The principle is that in every question, we've got 100, a 10 and a 6, and a multiplication and a subtraction. So there's less variance than children might traditionally have experienced. They may have been used to seeing different numbers, different operations, and there is less variance. Like a science experiment, if we want children to notice specific aspects, if we keep everything else the same, it draws their attention more directly to the effect of that one individual change. And so let me kind of share through this little sequence. So we start with 100 subtract 10 multiplied by 6, and that is 40. And then what's the only thing that changes for the next example? It's that now the 10 multiplied by 6 is bracketed. And what is the effect of that change? Well, actually, there is no effect of that change because it doesn't change the order of operations. And actually bracketing that is trying to highlight that fact. Now, of course, the change is the position of the bracket. And what does that one change show children? Does this affect the answer? Now, of course, in this instance, it does. And then it might be, now I would choose, what is it? What are the things that you will draw attention to? Because you might be able to draw attention to everything. But perhaps it is here, like a question that could be asked. It could be here, well, will the answer be to the next question be larger or smaller, and why? And making that generalization with this one change that exists, subtracting less, multiplying by more. And then I could point to those last two questions and say, is our expectation that the answer will be the same, given that we know we do the multiplication first? And I often like to throw in another little, the last question, some extra element, which we have here in the fact that we have a negative number to finish with. So let me give you these two sequences, and actually I'm just conscious of the time. We've got about 6 minutes, but I just wanted to finish here. And so what will this little sequence draw children, either sequence draw children's attention to? Now, can I suggest that you actually start with the Roman numerals and then move to the sequence on the left, given time? And the idea with the Roman numerals essentially is that rather than giving children a load of 4 different Roman numerals to find, by just focusing on one. Now, again, I would generally go lowering the challenge so that children are able to explain the relationships. Now, here you could say the challenge is relatively high to begin with, but what I'm doing is I'm trying to only use one Roman numeral because I want to draw attention to the specific structure of the Roman numeral number system. And to look at these individual effects. So rather than me explaining that, let me have a go and see what you draw from that, or what we want children to explain or notice, or what we could potentially draw out with the sequencing. So again, have a go at that. If you get the time, have a go at the example on the left. And again, just simulate your thought on the use of variation. So I will, until anyone from the panel prompts me, stop talking for a few minutes to give you enough time to have a go at that. And again, any things that you noticed or comments that you had, if you, of course you'll need some time, but if you put them in the chat, that's always welcome.
This is an absolutely brilliant activity.
Thank
Yeah.
you.
I think everyone's probably revising their Roman numerals right now.
There's a key at the side there for anyone who's
Yeah.
one day.
Yes.
Marvellous.
Yeah, and that was important putting that there as well, because to focus, so that the load is lessened in that regard. Again, if I give everyone a minute or so, and then comments coming in, and then we'll...
So the comments about the order affecting the answer.
Structure of Roman numerals.
Yeah.
Generalising starting to come through as well, I think, isn't it? When you start to be able to see a link and a connection.
In fact, if you don't mind, everyone, and look away if you don't want to see them, but what I'll do is I can't see what I'm...
So somebody's written, it's really making me think about the 10 and 5 boundaries in Roman numerals.
Yes. So what I'll do is I'll actually put the answers in there as well. Because again, I would often think when I'm using the sequences actually in the classroom of, it might be and thinking about when we give the children the answers. So do we give one and then talk about the relation to the next, or maybe we could put them all in and ask children, what do you notice, or what could you explain, or, and then again, can children devise their own sequences, which can be where we can move towards. And I guess what I'm trying to do in this example is draw attention to the fact that Roman numerals, if we say it's like an additive number system, where each time we add a symbol, we add we're adding the amount with specific exceptions. And so, like when I go from XLIII, and I have to add one more, actually, then I get to this point where I need to do one less than 5 rather than 3 ones. And similarly, how can it possibly be that we have fewer symbols to make 10 more? Because of course the X in XLIII and 43 is subtracting a 10. And so it's trying to draw children's attention to those specific aspects. And so just using the same symbol. And that's the kind of the fundamental idea. So again, I am conscious of time, and I'll also just kind of invite comments and things, and we've got time for questions and so on. But as techniques, I hope these ideas of using contexts, thinking numberless to model and break down in different ways, but it will all these vehicles ranked by difficulty questions, and the small difference questions help to think, right, I'll be able to make the mathematics here accessible, but then there's also this great opportunity for stretch. And again, my sincere hope is that you'll find everything abundantly generous on the website. The lessons are all there and are all free. icmaths.com, they're still up there. They will be, as long as any children might be at home, they'll remain there. And obviously all the resources as well, hopefully you find them really, really useful. And again, and I guess I kind of open up to comments that are coming through, panelists, and obviously any questions.
Thank you. I think my comment first of all is it's been really valuable to be in the learner seat this afternoon and kind of experiences as the children experience that remote teaching, because I think what you realise is how long it takes perhaps to process a slide and to kind of get your head around the information that's being shared with you, and how again it's really important to have a few really rich examples rather than loads and loads of different examples. That makes sense. So you can really get to grips and talk about and grapple with one or two really good questions in remote teaching, again, so children don't feel cognitive overload or overwhelmed or lose again the thread of the lesson almost. That's something else people have found this afternoon.
And I think that kind of comes back to that thing of what we celebrate, and then having fewer questions where we draw out more. I think that's perhaps a manifestation of that.
I think there's been a lot in the chat as well about what people are using and where this fits in. And if you are using something like the White Rose and you're subscribed to that, what is great is that they now give you the PowerPoint, and you can then embellish the PowerPoint and add in your reasoning and problem solving and enrich things. If you've got access to Gareth's material, it's so snippable. I think that's what teachers love about it as well. You snip it out of the ebook and you pop it in. either at the start of your lesson, you can record yourself doing it, or just send it as a PowerPoint to the children, or it's additional to whatever worksheet you're creating. But you know, it's about kind of trying to produce at home what we would try and produce for them in the classroom and staying true to that. So, you know, we're always recommending your resources as a place to go to if you want something that you can take with it and off the shelf and just go.
And always using them as well in the classroom. They're so carefully thought out, and whilst it often looks like a simple few questions, there's evidently so much thought behind every single question that's asked. I love your deconstructing questions. I just think that's so powerful, and you know, it's something that teachers talk about all the time, that children can't access this problem solving, word problems and things. So I think those are one of my favorite things there. You know, really great.
Thank you. And that's something I have to say I'm fascinated by, is how children access and how we actually build effective teaching into unpicking problem solving. And I'll spend many years battling with that, and I'm really looking forward to getting in touch when I've finished my current writing project with as many teachers as possible, pick as many brains as possible. So that'll be an open invite. I'll be writing about that on the blog, which is underused. I'll be writing about that on the blog soon. So again, it'd be really good to get as much involvement in that as possible.
We've had comment from Kathy, one of our colleagues, who has said that she's used your lessons both for homeschoolers and in-schoolers during the first lockdown, and a huge thanks for that. She says that's been absolutely brilliant. And
we've had thank you from parents as well, so us teachers that, you know, all often juggling parenting as well, so great to see it as a parent helping their children at home too, so that's really great.
Could you just sorry Gareth, but would you be able to also promote your website again, because one or two people didn't quite get the link to it, so would you let us know about it?
Yes, I can. Well actually what you'll have here is me trying to, this is where my internet crashed, so apologies it's not already up. It was there. I've never run faster down to the router in my life. You see it now?
Yes, thank you.
Yes, excellent. Right. Well, the first thing I should say is that this will take a little. There's lots of free resources and games that are on the free resources pages, early number sense and so on, and bits there. There's some home learning games that people can access. The actual lessons that I've referred to have, since lockdown, they've actually been organised, because they were presented as a daily lesson, and a new lesson would appear each day at the top of the screen. Over the summer, they were grouped by category. So there we've got like all the year 3 and 4 lessons coming up. So the little YouTube videos, which generally kind of somewhere in the 8 to 12 minute range, with the tasks underneath. So there'll be kind of 50 lessons or so in there. For information about all the products and things, so IC Reasoning, for example, the 2 new ebooks, IC Reasoning 5 is there. There's free samples for the IC Reasoning 3 and 4, which I'm in the process of finishing as well, that are available. So that's all there. And there's samples of everything and little video clips to show what they'll look like. So I hope that they practically make a huge difference. And for me, I wanted to get my ideas and thinking in as many classrooms as I possibly could. And so I've tried to make them as affordable as I can. And it was basically born from doing a training event where I suggested, well, here are some techniques you can use to embed reasoning in your classroom. And a teacher very helpfully and very honestly saying, Gareth, I just don't have the time to do that. So hopefully that really makes a big difference for people on a day-to-day basis. So again, there's lots of little bits here, little maths games that I keep updating. And anyone, I'm always looking for suggestions for new content and ideas. In the long run, my hope is to provide some guidance for teachers and some little clips. And it's just with 2 daughters at home, and I've got quite a lot on the plate as it happens, but that'll be something for the future for sure.
Excellent. We had some great comments actually today in the chat. Someone said, thank you for brightening up a tough week, Gareth. They really appreciate that. Someone said the odd one out activities you talked about at the start are absolutely brilliant for remote teaching. One of your colleagues and a parent said they've used your first class maths and now have 2 children of their own who are A-star mathematicians. And I think I love this comment. you've given this person a real buzz for going to teach them more mathematics now. So thank you so much. I'm sure there's other great comments just coming in as I finish off there. So.
Fabulous. That's great to hear. And again, if there's anyone equally, if you're thinking, well, what does this concept, what does this look like in this curriculum area, or if there's something, an issue, it'd be great to feel like you can voice that. And yeah.
There's some real gratitude coming through from teachers. Really, I think people are inspired and so widely using your resources, and I think the gift of time for busy teachers to is so gratefully received.
Yeah, I mean, I have to say that was really born from I was so what I was 3 years ago. I was still working in school. I actually have to say I loved it, just outside of Manchester, and I was full-time in year 6 assistant head and trying to do some maths training as well. And I just knew that there was such a big difference between the principles of what I wanted to be able to outwork and just the time pressure. I had 2 young daughters. And I really feel for teachers, and particularly now, the time pressures that I would live through, and still do to some extent every day, as being a massive driver in everything that I'm doing at the moment to try and help teachers daily. And again, all comments or thoughts, and I want to spend more time communicating with teachers over the next 6 months. And again, lots of ideas for how I can possibly do that, and not to communicate my ideas, but actually just to understand your context better, would be wonderful.
Well, as a maths hub, we're always really keen to collaborate, Gareth. So if anything you want to do with us and our sort of, again, wider teams, we would absolutely love to work with you further on that. So.
Yeah, great. And it's great the world is opening up now to some extent as well, with not in terms of obviously with lockdown, but it's in terms of I'm able to communicate and work with people more widely like this to some extent, which is a privilege.
Well, I think there's huge interest today, as you can see from our numbers. It's been lovely to have over 300 people with us for the afternoon, and I know people feel really inspired now, and say they've learnt reams and reams, and are now looking forward to planning their maths for next week rather than dreading it. So they're really excited as a result of having some inspiration this afternoon. And we work with lots of different teacher research groups across Sussex, early years, all the way up to secondary, of course. So we would love to collaborate and talk about again how we can trial your materials and give you feedback and keep on discussing with you. We'd love to do that.
Yeah, fantastic. And just as a side, one thing that I will like to, that I'm looking forward to doing. I do some work with the NCTM work groups in the Northwest, and we've been looking at running innovation projects around developing problem solvers, and that's something that I find really fascinating, and I'd love to get. Again, the thing that I'm really going to I want to engage with people on is the challenges that you face in developing problem solving, and because I think effectively teaching problem solving is a very difficult thing to do, and to plan for, and I want to really engage with that specifically, and I think that will be something that will be a big focus of me for the next few years. So really interested in everyone's thoughts around that.
We'd be very interested in doing something. We're working on we have an innovation project on greater depth, which is looking at reasoning and problem solving, but not quite from the same angle. So that may be something maybe we could collaborate on next year or later on this year.
Yeah, absolutely.
Problem solvers, definitely.
And if anyone's keen to join that, they can still, can't they, contact the hub?
Yeah, we're going to rerun the first session. So if you express your interest, we're going to rerun the first session and schedule that coming up soon.
Yeah, and again, hopefully with there's so many. I mean, the thing that I've learned is there's so many people passionate about maths teaching, and that being able to kind of have real, genuine collaboration and sharing the great minds that are around and is enormously powerful. I think hopefully that's something that we'll all be able to leverage even more in the kind of upcoming years, really.
Just had a question in from someone who wants to know how they can get involved in the Maths Hub. What I'll do is, rather than have a deluge of emails for poor Tisha again tomorrow, what we'll do is we'll get Tisha to send out links from today's session, and also any live links of where we're still recruiting to any of our work groups and opportunities. I know, again, we've got this subject knowledge enhancement coming up, both for TAs and for teachers, starting very soon. You can sign up for. Again, it might be the ideal time for your teaching assistants to get involved in that. And where there's other opportunities, we'll make sure Tisha at the Hub sends everyone who's been on today's webinar all the links you need, to save you having to chase her. She'll just send it out as a matter of course to all of you, so then you can peruse that and see what might suit you best. Thank you.